Okay, welcome everybody to Data Science in 30 Minutes. My name is Robert Scroll. I'm a data scientist in residence here at the Data Incubator. For those of you who haven't heard of us, the Data Incubator is a data science training company. We like to train people to do data science on real-world problems with real-world tools. We do that in a couple of different ways. We have a data science fellowship. This is designed for people coming out of master's and PhD programs. If they're interested in entering the industry as data scientists, we have a 8-week, very intensive fellowship program that gets them up to speed and starts that job search process for them. It's completely free for the fellows attending. You can apply at thedataincubator.com. Our application for the winter session is starting soon, but you can go ahead and sign up today, and we will let you know as soon as that application is opened. For those of you who can't take 8 weeks out of your lives to learn about data science, we also offer some online courses. These are in the evenings, usually 2 nights a week, designed for people who are already working professionals to expand your skills to gain some data science knowledge. Our Data Science Foundations program and machine learning classes start September 11th. But if you sign up by this Friday, that's August 24th, you can save $400 off of that tuition. Once again, that's at thedataincubator.com. And we also do corporate trainings. We can customize our content for your corporation. We've done trainings anywhere from 2 days out to 8 weeks. So do let us know. We're happy to work with you to get the training that's right for your particular organization. Once again, all of that information is at thedataincubator.com. But that's not why we're here right now. Instead, we're here to talk about data science in 30 minutes. This is a monthly series we have to discuss data science and how it interacts with the real world. We've had a number of wonderful speakers in the past, including Cook Barn, coming as the Director of Data Science from Booz Allen Hamilton. We've had Andreas Mueller, one of the co-creators of scikit-learn, a package that many of those data scientists out there probably recognize, as well as Sam Swift. He is the Vice President of Data Science at Betterment, and we're particularly proud of him as a former Data Incubator Fellow. All of these previous sessions, they're available on YouTube, so if any of these are interesting to you, go ahead and check them out, but not right now, because we got a wonderful talk today. But before we get into that, a little bit about the format. So we're going to have a brief presentation here at the beginning, a little conversation about data science. As we're doing this, if you have questions, you can type them into the YouTube chat window. You need to be logged into YouTube to do this. But once you are logged in, you can type in questions. We'll assemble those, and we'll get to those about 20 minutes into our conversation. So I think that's all the preliminaries. It gives me a great pleasure to introduce to us today Mike Tamir. He is the head of data science at the Uber Advanced Technologies Group. He also teaches data science at Berkeley, but he's not actually talking about either of those today, at least not as his main focus. Instead, we're going to talk about his project, FakerFact.org. This is designed to use sort of modern machine learning technologies to look at news articles and understand, are these proper journalism? Is this fake news, or is it somewhere in between? So welcome, Mike.
Thank you. Thanks for having me, Robert.
Do you want to start off telling us a little bit about the project and why you felt this was something that could be built and needed to be built?
Sure. So we started thinking about this project within my lab as one of the research projects that we were working on about a year ago. And of course, the first thing that we did was start pulling down the data. What really got me excited about this kind of project is, a lot of the major players have been really struggling with figuring out how to handle misinformation. This is a problem with branding and with advertisements. This is certainly a problem in social networks, sharing and propagating. There's a lot of data that actually news that is sensational and that is often labeled as the broad brush of fake propagates more quickly because of its novelty. On the face of it, this seems like a really hard problem. When you, as a data scientist, in particular someone who's using machine learning, you need a lot of examples in order to train the algorithm to do something, or at least you need multiple examples. And when you're talking about news is new. And so when it comes to figuring out new points of fact and whether or not they're true or they're false, that can be a really challenging problem to solve with machine learning, even with the best deep learning algorithms. When we first started talking about how do you attack this problem, it quickly shifted from thinking about solving this very difficult problem of how do you detect the truth, which is something that humans have been doing roughly for 50,000 years, as long as we've been speaking at least, to how do you detect something that's often correlated with whether or not someone's sharing the truth or not, but is not identical to when someone's trying to manipulate. There's a lot of great research in the field of psychology over the past several decades at this point that shows that when you are emotionally engaged, when text or video or imagery engages your certain like fear triggers or anger or all sorts of different emotional hooks, the more emotionally engaged you are, it turns out the worse your cognitive functions. Your cognitive abilities get depressed when you care about what you're doing, which is a radical defect, you might think, unless you take a moment to consider how we evolved, and we evolved in a time where maybe it made more sense to just run away from things that might seem dangerous rather than overthinking it first. So that was the crux. That was the idea of how are we going to attack this problem. We're not going to look for truth and falsity of what's being said, at least not yet, not to start. Instead, we're going to look for what is trying to trigger those emotional reactions. What kind of text is built to depress our cognitive functions, and what kind of text is built to just share information. So it's sort of like the Joe Friday, just the facts. And the hypothesis is that the text that's focused on just sharing the facts, that's not only going to be good journalism, but that's going to be journalism that's focused on sharing true, not just things that sound like facts, but real facts, right? The sort of thing, the truth is truth, so to speak, facts. And that's really what the detector is built on. It's about creating an algorithm that can sort through examples of things that manipulate or that rile up those things that depress our cognitive abilities versus those things that at least sound like they're sharing facts and only the facts, whether or not they turn out to be veridical, so to speak.
Mm-hmm. And are these things that you think authors are purposely putting in there, or are these just things that authors do somewhat unconsciously based on their knowledge of writing, their experience of writing?
It's probably a mixture. It's probably a mixture of, I think good journalists tend to find that they get better responses from good storytelling. In fact, good journalism in a lot of ways is good storytelling. Mm-hmm. And so there's a lot of downward gravity towards sliding into this narrative form and this form of sharing information, not in a way that's just about sharing information, but unfortunately about getting doing performance and doing entertainment and influencing your authorship. And we're all humans, and so we all like to influence. And I'm sure we've all picked up on the subtle hints of what works and what doesn't work, and what gets a good response and positive response, and what sometimes is not as positive. That's great when it comes to entertainment. That's great when it comes to getting people interested. Unfortunately, it's not so great when it comes to keeping and maintaining a very high standard of information sharing. And we've gotten to the point right now where really we need to put some friction on that. We need to, even for earnest, real journalists who are doing their best, they could use help too, hopefully. And if we can do that algorithmically and create tools that that might support that, that's hopefully a win.
Yes. So what was your strategy there? How do you start detecting this sort of manipulative writing?
Yeah. Data incubator. You're in the business of training new data scientists, and I'm sure one of the first things that you do is teach them, don't build the most complicated thing first.
Absolutely.
and so once we pulled our data and we started getting some good examples of positive and negative training labeled data for each of our labels, for each of our classes. We have several: journalism, sensational, satire, unreliable, and opinion. We just wanted to validate the hypothesis: is there a signal at all? And so we did the simplest thing possible. We pulled down these off-the-shelf, very easy paragraph vectorizers. There's one in Gensim. There are ones on TensorFlow Hub now. There's fast text, and that's very quick, right? That's just a matter of processing, putting it through a vectorizer, throwing it through a classifier, and you've got an answer. And that certainly validated our hypothesis that there is some signal there, right? That you can get non-negligible precision and recall from for each of these labels in a variety of data sets. There's a lot of data management that's involved too, and this is also something I'm sure that you're teaching your students.
Absolutely.
If we just took the native scraping of what we've done is we've done a biased sampling. In fact, we biased it very specifically on wherever the heck we spent our time scraping and how long we spent it there, and probably what was easiest to scrape, because that's going to guide how quickly we scrape it. So stratification is an important sort of like first level application for a real machine learning product use case this is a great example of. We had to stratify our data. We had to stratify for subsections in journalism articles, or articles taken from their subsections in journalism. We had to stratify for different kinds of data, right? And these are not all orthogonal. It's not. It doesn't stretch the imagination to think that some of the articles that were clearly in the unreliable category also counted as opinion or appealed to sensational. There's also a lot of disambiguation that's required. It's surprisingly difficult to separate out things that are, at least in 2018, news and sensational from things that are actually satire. And so managing all of those data sets, curating those data sets, and doing all sorts of semi-supervised reverse bootstrapping processes in order to make sure that you had pure examples of each of these is another big part. Before you even start with the deep learning, that has to happen.
So where did you start gathering data? Was there a pre-assembled data set that you could bootstrap off of, or you were starting from the web?
There are some like Kaggle open source data sets out there. There are, in fact, we're thinking about actually releasing some data sets to help. This is a public good project, and so what we'd like is for everybody to start working on these projects. And since we put all this work into data curation, doing something like a open sourcing of the data to let everyone try their hand at it is something that we'd like to do. How do we do it? Well, it's a process of some examples are very clear, strong examples, right? Reuters and AP data sets are going to be they're above reproach by according to most standards. Other newspapers or websites for newspapers hosting newspapers. There are there are consensuses for both among left and right of whether or not there is bias built in, and we were very cautious not to train for real journalism on anything that there's strong consensus or even some consensus that that this is biased. This is a biased source. So that means that different newspapers or different cable news channels, both on the left and on the right. And I'm not going to say anything that might make people feel bad if they work at these news sources. But we. Some of them are mixed bags, right? And so they have a portion of them that are very clear examples of journalism, and a portion of them that are maybe go across the line. And so we had to be really careful not to use those whole hog as examples of journalism or examples of sensationalism, because that will confuse the model. And what we discovered through much experimentation is that actually when you train on a low entropy label set, so you try to minimize the ambiguous cases, the cases that are slightly journalism but slight sensationalism, journalism but slight hints of sensationalism or opinion or even unreliable signals. And you train your model on that, the model is not just doesn't just perform worse. So a model trained only on those pure examples will perform better in detecting pure examples. It also performs better in detecting those gray area examples and being more nuanced. And that's an important lesson for that generalizes to other examples when you're working on projects with a certain level of degree of complexity in your input data space.
So your goal here is, I want a training set where it's clear that it's in class 1, clear that it's in class 2, clear that's in class 3. And if I have training data where that's not clear, in fact, I do better by removing those from the training process.
Yeah, and that doesn't work in all cases, but it does seem to work for this use case. It actually gets better at showing a partial score for ones that are partially sensational, rather than training on it and showing that it's either fully sensational or not, or training on the fact on the labeling that's fully sensational or not.
And do you think that's related to the fact that these classes are not exclusive, or is that an unrelated issue?
That's a good question, and it's something that I think we need to do more experimentation in order to really develop a let's face it, a speculation on what that root cause is. I think it's intuitive to say that whatever spikes for these very clear cases that are maybe strong signal for sensational, if you have some of that those elements in a otherwise very responsible journalistic article, that should trigger some certain amount of signal. And I can talk a little bit about what the more the current iteration algorithm looks like.
I think that's probably the obvious next thing is, okay, now that we have some signal, we have some good training classes, now we actually want to make useful output, not just on one of these classes, but on all of them. So how did you attack that problem?
Yeah, and so we still are approaching it from, we have a different classifier for each label, and part of that is because we don't see them as perfectly orthogonal. We have a wiki one too, which we threw in there for both for Wikipedia, which is where the label comes in, but also for articles that are a little bit more scientific or are bent at sharing information, but not necessarily traditional news journalism. We wanted a classifier in there to help out with capturing those examples. So the sorts of techniques that we use, and I'm gonna go ahead and describe a number of them. We use all of these in all sorts of different varying combinations, and on literally a nightly basis, we are experimenting with new versions. So while we can construct several different algorithms using these techniques, it's bound to change by the time this gets posted even. So let's start from the beginning, which is vectorization. So I talked about fast text and Jensen, word to vec. And so that's really stage one. We need a place to start with, which allows us to just represent our words in terms of vectors, and vectors that have a non-sparse representation, that are spread, or where that information is spread over a sufficient number of degrees of freedom. Usually it's around 300, but not so many degrees of freedom that you really lose that signal. Another big benefit of all of these different word embedding techniques is that unlike classic TF-IDF and one-hot encoding, words that are similar tend not to be orthogonal, right? They tend to actually have closer proximity. And this has been part of the reason why we can do so much more with text than we could even 5 years ago, is that we are now able to embed words where that semantics is captured in the relative position of the words in which you've embedded them in the vector space in which you've embedded the words. So that's level one, right? If you want to create different paragraph vectors, there are several techniques. Some of them train actually embedding the paragraph itself by trying to figure out what kind of vector representation fills in that added context, that missing context. So they try the algorithm will do the same process it does with the words, but it'll have this extra context vector, usually you'll call it, representing the paragraph of the document, and it'll pick the parameters for that as it's trying to do the vector embedding, or as it's running through the words themselves. But now it's backpropping to update the vectors of the paragraph. So that's really, and now we're at that level one. Build the simplest thing first. This is simple by 20 years. Moving on from that, now we have a lot of great options, right? And so if you have a sufficient volume of data and using all the processes that I just mentioned, we were able to get millions of articles for training data, and this opens up the box for doing real deep learning, not just neural embedding, which is a shallow process, although a good one. So it lets us do things like update entire language models. So this is where you're not just doing one layer, but you're doing several layers. The first layers typically will learn and start encoding different structure in the language, and then the last ones will start doing word-specific semantics. And there are all sorts of techniques for doing a staged freezing for when you update those models. So you can do transfer learning and all sorts of things. And there are TensorFlow pre-trains out there now as well. There are attention-only mechanisms, right? So attention is all you need is something that I think we're maybe 9 months or so that's been available on TensorFlow Hub, and this comes from the Google research project where it's just using attention mechanisms. And attention mechanisms are these techniques where you go through the words, say in a sentence or even in a whole paragraph, and through various comparison mechanisms, you assign a weight to each of the words. This is paying attention to the words that are important, as you go through it, and then that gets pushed up as an added context vector, or maybe the only context vector representing the importance of the meaning in that sentence, right? So that can be pushed into softmax, or you can just take linear combinations. There's a lot of options there. There's also, of course, our friend, the long short-term memory neural networks, recurrent neural networks, and so these are something that have this is a technique that's been around for decades now, but is very good with text. We found because LSTMs, long short-term memory networks, will look at things in sequence. They're very good for time series in general. They're good for looking at equities, looking at anomaly detection for continuous telemetry, and looking at text. And one of the reasons why they're really good at looking at text is because it's able to keep track of things that we naturally do when we're speaking and listening to language. In particular, where we have relative clauses, and we have punctuation, and we have adjectives and prepositional phrases, and all these things that we in our own short-term memory store, so we can remember what's referring to which part of the sentence. And and with LSTMs and keeping this track of the cell state and passing along hidden state, it's able to keep track of those things too a little bit better than, say, traditional RNNs, which do not do so well with that, especially with things like refreshing and punctuation. Yeah, so we've got, I've just laid a lot of different Lego blocks,
of possibilities there
on the table. So you can build, now you can start building these up. So LSTMs, you can read sentences from backwards to front and from front to back, and it's called bidirectional LSTM. You can create by the end of that, so you've got one that went from back to front, one that went from front to back. You can put those together, and now you have a complete context vector. You also have all of the different vectors that are sort of like meeting in the middle, right? The front to back part and the back to front part, and you can take those and you can start fitting those into attention. And so far, everything I've just described is actually should be very familiar for anyone who's been following things like neural machine translation in the last 18 months, because this is exactly what's done for neural machine translation. You take you encode that, you maybe throw it through a attention mechanism. So now you have an attention context vector, you have the end-to-end vector, and then you feed that in, and now you've got it's called an encoding of the entire sentence. And now you can use an LSTM and neural machine translation to start unraveling all the information that was captured in those context vectors and start writing or rewriting the sentence in a way that now has been trained to how you do that for German or how you do that for Spanish or whatever it is. It's good for abstractive summarization. So when you're doing summarization of a long piece of text, you capture that information in a small vector or relatively small vector. So you've compressed a lot of the information. You maybe let loose some of the information that's not as germane to, it's more of a fine-grained detail to the whole text. And then you unravel that in maybe in English, from English to English or from German to German. And now you've not just picked keywords, which is non-abstractive, but you've actually found out what's important to the entire text, and you've started to write that out. So this is the sort of thing that Socher and his team, for instance, have been doing over the past year for text abstractive text summarization. And you can do it for fake news as well. Now what we're doing is we're creating these rich vectors, and we can do this in several different layers. You can combine all of these different ways of representing text into all sorts of different vectors. You can throw that into dense nets if you want, and after much experimentation, you find combinations that will actually do very well in representing articles in a vector space, a journalism vector space, a sensational vector space, and now you can just build a classifier on top, some softmax, whatever it is, to slice away what zone is the journalism zone, what zone is the not journalism zone, and actually add the softmax add a number between 0 and 1 to almost score how much you are in that zone or one zone or the other.
And when you're doing this development process, is that final score the only thing you're looking at, or do you use sort of intermediate steps of understanding how well you're summarizing text to judge whether those low-level things are useful or whether they're not working that well for your particular domain?
Yeah, so we have been focusing primarily on precision and recall scores. We want total F1. We do like to bias towards precision because Walt, the name for the quote FakerFact AI that we created, named after Walter Cronkite, was we want to make it a little bit more generous and careful, and so we do actually do things like bias the entropy we do like cross entropy and loss function and bias it towards precision. And when we see that maybe the algorithm's being a little bit too aggressive in practice, we can do that. So precision is one of the most important ones, but of course it can't be the only thing. Otherwise, I've got a great precision algorithm for you. It never guesses yes.
So since you've mentioned it, let's talk a little bit about Walt. This is the end user interface. Why don't you start just by telling us how you decided to present this to people who don't necessarily know what deep learning is?
Yeah. The first thing I should say about deciding to do UI is that I know nothing about UI except for the fact that I am a user from time to time of different things. We've experimented with a lot of things over time. As a data scientist, I like charts, so we ended up using it's sort of like a FakerFact flag where it has different bars that show the power, the strength of the signal for each of the different of the different scores. So if you have a high journalism score, you might get a very strong bright green bar for journalism. If it's something that that is maybe a scientific journalism article, you might get strong bright green for journalism and a strong bar for wiki, and hopefully low for the other ones. Often, and this sort of brings us back to where we started. There has been a shift in culture of making making your articles, even your news articles, if you're a professional journalism, a little bit more sensational than maybe they need to be. And so often what you'll get is even from reputable news sources, strong journalism, hopefully, but also maybe hints of sensationalism or opinion or even unreliable scores. And that happens, especially when it's a sensational topic. To like today, that there's evidently been a lot of news in the legal realm with people, people that have been on trial or been waiting for their trial, and so that tends to spike in the sensational realm.
And we should point out that this is available for everyone to try right now at FakerFact.org. That's FakerFact.org. Go check it out, and you can play around with it. You submit your own articles, and I guess you have to go out and scrape those articles as soon as they're submitted, run through your algorithms, and then give us a result.
That's right. Yeah, and sometimes it doesn't scrape exactly the text, so there's always an option you can copy and paste in the text box as well if it doesn't capture it. And there, we created Chrome plugin and a Firefox plugin, and hopefully make it as easy as possible for people to play with and to check out. We are this is an active project, so I should, especially since there is I'm sure very talented data science community in that you are a part of. Please feel free to reach out if you're interested in working on something like this, because we're always looking for talented, excited new data scientists to help.
Great, thank you. So I think we should go and get some of the questions that have been coming in from the audience. Just a reminder that we're still happy to take even more questions. Just type them there into the YouTube chat window, and we'll see how many we can get through before we have to call it an evening. So the first question here, I think we've addressed this to a little bit, but how domain dependent is this tool? And how did you sort of decide which domains to focus on with your current analysis?
Yeah, that is a super important question, and something that there was when we first started working on it, a couple of apps out there that that just were domain checkers. In fact, I think there's some now that like Google has a domain checker app, and we made the active decision not to do that. First of all, that those apps are, they're out there and people are using them, but also doesn't, for an interesting machine learning problem, we probably could get a lot of signal by looking at the source. And in fact, maybe that's even going to be the dominant signal. Unfortunately, what that also does is it opens you up to unintended bias in your algorithm. And that's something that we really wanted to be very careful about, was not to introduce bias left and right, or bias for sensational, not sensational. And if you label an entire domain as one of these categories, what ends up happening is then you end up making mistakes. And as I mentioned, there are URLs out there that have a mixed bag of true journalism that's properly reported, and maybe some other text that's not so much or not as well reported, or it doesn't hold to the standards of not manipulating its audience that we really want. So we sort of handicapped our algorithm by purposefully not letting it ever look at the URL. It looks at the text on the page. Specifically, it looks at the body of the text and the title, and that's it.
So we've already talked a bit about some of the models that are under use, but there's another good question here. How do you deal with false positives? And I imagine that occurs both in when you misclassify something, as well as are you worried about false positives in your training data set as well?
I'm always worried about that, and my advisor and my mathematics advisor was one of the first to prove one of these computer proofs for the honeycomb problem. I believe I saw him give a talk about it once, and he explained how in such and such year, reporters asked, "Is there a bug in your program? What's the chances?" And the graduate student who answered that question said 100%. And I think that's a pretty apt situation. There's no doubt some false positives. There are no doubt some mislabels, and the goal is to through things like reverse bootstrapping to remove that noise in the label set as much as possible. It's hard to do. It's hard to do at scale, and so while we make every effort to do that, it's bound to happen.
Yeah.
Hopefully very little. And by the way, the bug was found. So now there's only n-1 bugs in the honeycomb proof, and that was reduced. Now for there's another question, which is what happens if Walt just makes a wrong answer, and guaranteed Walt does make wrong answers, especially since we throw new experiments up there all the time, and so it's bound even we might do a backslide, right? And so there is an option to actually give feedback. Now of course we need to be very cautious with how we how we ingest that feedback, because otherwise what we're doing is a sampling error all its own, which is sampling the whoever the users are at any given moment in time when we do that. So we have all sorts of, and this is another active research project, figuring out ways of stratifying the sample, the external raters, so rate the raters. There's intriguingly little prior art here, so it's been a really fun project to think about how we do that.
I know there's many websites that have had this problem of the meta moderation, so I don't know if any of that has actually made it into the literature or not.
There is surprising. I thought that it would be a much more well-trodden area of research when I first started looking into it.
Interesting. Another question here: how do you deal with sarcasm? I think that may actually show up partly because one of the things you try to detect is satire. Is that correct?
Yeah, that's right. And sarcasm, while another phase of work that we want to do, or the next phase of work that we want to do, not just giving a number, but actually giving more insight into, well, so this it says it's unreliable. Why? And with all the work that we put into the latest algorithms using attention mechanisms and things like that, it's not that many more steps to start actually showing what's spiking, what's really which sentences or which sequences of sentences or what areas, what paragraphs are more or less influence on particular scores. And so that's something where, and if that's intriguing to you, that's something that we are going to be moving into in the future for those of you who may want to contribute to the project. In particular, while I have not opened up that box yet, or we have not opened up that box yet, I would hazard to guess that that both with satire and probably with sensational and opinion, that you're going to see sarcastic sentences more often identified as culprit sentences than you will with journalism.
Interesting. Thank you. We have a couple of questions sort of about other possible use cases for this sort of design. One is about detecting hate speech or other hateful sentiment. I imagine it's not so different.
It's not so different. We have not done. There is in those first rounds we did do early signal on that. Hate speech, for not for better or for worse, for better, there are not as many millions of articles easy to find out there in the world. So we have not focus as much effort in hate speech. There's also something worth noting, and one of my colleagues actually here, my Uber ATG colleagues wrote some interesting work on this. Hate speech tends to be a little bit less subtle. There are some great there's some great literature that came out of Yahoo Labs, I believe, where they worked on this, and they saw that actually TF-IDF does not get dominated terribly much, even from regular paragraph vector applications. And then the reason why that, or the speculation why that might be, is because something that is hate speech is going to have very specific keywords. Now, I think that there is a hypothesis worth exploring, that there are more subtle dog whistle type turns of phrase, or macroscopic, like whole article subtleties with hate speech that we might be able to detect with this more robust architecture. It's something that I'd love to start devoting time on. So it will be something that we use as a use case, just not just yet.
Not yet. But it seems to be almost dog whistles. They're relying on the lack of knowledge of the audience, of the general audience of these signals. Whereas I imagine, as long as you have some examples, it shouldn't be all that hard for a machine learning algorithm to learn those dog whistles.
Yeah. I think that's also something that talking with sociologists, there's a lot of work to do there. It might just betray my sensitive palate, actually going through those and going into incognito mode, so Google doesn't think I've gone completely crazy. It's not the most fun thing, so that might have influenced prioritization as well.
So in similar sort of line, how easy is this going to be to translate into other languages? That's a question specifically about Burmese, but I imagine that the answer is going to be more or less the same for different languages.
Yeah, it is. I think that, obviously the architectures are probably, I suspect similar architectures are going to work similarly across different languages, although it's not always the case. From machine translation, we know that that's not always the case. However, one thing that's important is that you need to be careful about your data sets, and when we could. One might think, oh, well, we could just translate all the data that we have for English over to Burmese or whatever the language is, and I suspect that would be a mistake, because you might actually lose important signal. So the best way to do that would likely be to get fresh data with of each of these examples in any new language that you want to use.
Yeah, it sounds like a lot of the signal you have is coming from not necessarily the words themselves, but the structure of those words, and that's going to be very influenced by whatever translation mechanism. Presumably. Yeah.
Although, it's worth just saying a couple words about pre-training. We have done a lot of pre-training experiments as well. So there are pre-training surprising patterns between pre-training for, say, journalism and wiki and unreliable, and different pre-training the set. Sometimes doing it fresh is better. Sometimes pre-training. There is this sort of folk wisdom that pre-training for images worked really well. Pre-training for text, not so much. I would say that while in general, it's certainly not as easy, not as straightforward. There are opportunities depending on your architecture, in particular when you have later DenseNet architecture to pre-train. Also with retention mechanisms, depending on how
you may not need a million different news articles in Burmese. If you can start with a million texts in Burmese, that may be enough to get you to the point where you can learn from a smaller corpus of actual news.
Yeah, or even pre-train in one language and then go over to Burmese. That's just a hypothesis, but that's something that I would consider exploring depending on the level of effort.
Interesting. Thank you. There's a question here, I think, related to the fact that you already mentioned getting people involved. Is this code available open source on GitHub at this point?
Not yet. So I think that's something that especially as part of open sourcing the data would be worth doing and open sourcing right now. Right now it is not. But certainly if you're interested, probably the info at FakerFact is the best place to reach out, and then we can follow up offline.
There's a couple of questions here, all sort of on the same theme, and you've addressed this a little bit already, but what are the best models you found here? And actually a question that I have is, how do you come up with new architectures? What inspires you as you're trying to figure out what architecture you should try next?
That's a good question. In some ways, it's just creativity. I am certainly one of those. I guess maybe I'm not sure what the right pejorative term is. Nerd is not the right pejorative term. It's much worse than that. That tends to look to information theory for when I think about what we're doing, and mostly when I think about how we're compressing dimensionality, how much information we're actually getting through differently, especially with dense nets when you have when you don't have just a flat structure, but you actually have to compress down from multiple different sources to a smaller vector. Some of it can be done just with experimentation, but this is expensive training, and yes. So you cannot check everything that you would like to train under the sun. Some of it looks a little bit like hill climbing. So you look what works, you go for that, and then you start figuring out other sections of the architecture when you're tuning, so you can kind of figure out different pieces independently. Although that is open to, just like hill climbing, it is open to its vulnerabilities. Something else that I tend to keep up on literature. Certain things that have that we've seen patterns even over the last year. So things like embedding different context vectors, not just in the beginning is sort of this trope that we see not just for the past year, but for years now, but allowing that to propagate all the way up through different parts of the pipeline, putting some of that information at the end, having highway opportunities for information, so you don't get, we're doing mostly LSTMs, but there is some dense net architectures, so that ends up, you do have some, even if you use ReLUs, you do have some opportunity for vanishing gradients, and all of this influences what we try and in what order.
But actually, that's very reassuring. Whenever people ask me what architecture they should use, I say, go find someone who has done it and copy theirs. So it sounds like it's the right place to start, at least.
Yeah.
Okay, I think we are running out of time. Anything else you'd like to let people know about before we wrap it up?
No, I think that this was a great discussion. Thank you again for having me on. Definitely, thank you everyone for listening, and again for engaging in this. And if you are interested in reaching out, please do. I guess one of the big takeaways that's worth punctuating is the place where we started. As you're building machine learning products, one of the most important things to do is think about how you're going to apply this. That simple step from or turn of the problem from I'm going to build a truth detector to I'm going to build more of a manipulation detector. It makes a huge difference in the tractability of the problem. It's been a slog, but we've gotten pretty encouraging F1 scores in each of these, and that's something that I don't think would have been possible if we had approached it from a different direction.
Yes, thank you. So thanks again, Mike, for sharing your work. Remember, this is at FakerFact.com. That's FakerFact.com. .org. I'm sorry, .org. Go check it out, play around with it. I've already wasted a couple minutes doing this, and I'm sure I'll waste a couple more later on today. I hope you've enjoyed this conversation. Just a reminder about the Data Incubator. Our winter fellowship applications are opening up soon, as well as some of our fall online courses. You can find out more information about all of those at thedataincubator.com, as well as more information on our corporate training programs there. So do check that out. Check out the other videos in the Data Science in 30 Minutes program, and we'll see you at the next one. Thank you all.